Hey, and welcome to my second smart home video. Today I'm going to be showing you the architecture of my smart home system that I developed in order to bridge from my old legacy EnOcean based relays and switches to a modern HomeAssistant based smart home ecosystem that is also integrating Z-Wave devices and can be controlled from my smartphone or from my computer. So here you're seeing a diagram that shows all of the parts. On the left side of this line, you can see the legacy EnOcean system. This is an EnOcean relay, and I actually have 3 8-way relays in my wall box. And each of these 8-way relays have 8 switches in them that switch each a light circuit, a 220 volt light circuit that is routed through the walls of the house, and each light circuit has a light attached to it. So this could be, I don't know, maybe even one of the lights that's shining on me right now. Each of these relays listens to 8 different kinds of telegram message on the same frequency sent out by a wall switch. So far it's not very smart. This is like a classical light switching system. The only difference is that there is no wires here, that it's basically going over a radio. Okay, so how do we make this smarter? So the heart of my system is right here. It's an embedded computer, and it doesn't actually matter what embedded computer you take. It just has to have Ethernet connectivity and or Wi-Fi. You could choose Wi-Fi as well. I just went with Ethernet because my house is wired for Ethernet. It's not hard for me to just wire everything with Ethernet cables, but it could have been Wi-Fi also. It would be the same thing. It also has 2 USB sockets that's used, and one of them has an EnOcean radio USB stick. So you can order these online. Basically, they can send and receive EnOcean radio messages. And that's very important. So that means that they can listen to the traffic that is going from these switches to the relays and basically let the computer listen in on that conversation. Now, I also have a second stick here, and that's a Z-Wave radio stick from AOTech. That lets me have a separate new radio system with Z-Wave switches like the wall mode that I showed in my last video. So this Z-stick listens to the Z-Wave communication. So now we have here a computer that's able to read out all of those radio messages. Now, also important is that the EnOcean stick can also send its own radio messages to the relay box. So now, if we are able to program this correctly, and that's going to be the challenging part, we can not only switch the relays from the EnOcean wall switches, we can also switch them from the computer. Okay, now this cloud, it represents, your internet, your home network, whatever. It doesn't really matter, but basically it's an Ethernet cabling for me going to my home router, and then that has either wireless connectivity to either my smartphone or my computer that I'm looking at right now, or any other computer in my house. Or if I would use a VPN, I can also do this kind of internet-based communication through the cloud anywhere. But one of the very important aspects is that this is not cloud connected. I really wanted to have a system that doesn't give Google or Apple or any of those other big players to basically see all of my home network communication, know whether my lights are on or not. They have no business seeing that. And to all of our dismay, a lot of the new smart home systems on the market, they're basically operating over, let's say, the Google Cloud, and or the cloud of any other of the smart home vendors. And it means that not only do those guys then know whenever you switch your lights on or off, but your system will not work if your internet goes down. So of course my system also doesn't work if my home loses power and my home router goes offline. But ultimately, if my ISP stops working, it will still operate, because none of this stuff here that I'm showing you necessarily goes over the internet. It just goes over my home network. Okay. So now let's talk about the software. Those were all the hardware parts involved here. The software that's running on this embedded computer is Home Assistant. That's very important. So there is Home Assistant running on it. Home Assistant is this open home automation platform that I can really recommend for everybody. It's super easy to use and it can create all sorts of automations. So there's tons of videos about this on YouTube, so I'm not going to talk in great detail about what it does, and I expect a lot of the smart home enthusiasts are already familiar with it and are using it. In addition to this, I'm running Mosquito. Mosquito is an MQTT broker. MQTT is a way to send small packets of information over the internet, whether it's on the same device or on different devices. So it's a very convenient standard, MQTT. I encourage you to look into that. And it has a good Home Assistant integration. Then what I'm also using here is Z-Wave JS UI. It's another software platform. It's free and it's open and it integrates with Home Assistant and it ties the entire Z-Wave ecosystem into Home Assistant. Okay, so then there is still a missing piece, and that's basically what I had to invent myself, which is to bridge EnOcean into Home Assistant. Home Assistant has some EnOcean support, but not enough for this project. So in particular, it does not support any of these wall switches that I had because of its unreliable communications nature, etc. I'm not sure what the reasons are, but the built-in support to Home Assistant is not good enough, so I had to create my own application. So let's now go into more detail about what this embedded computer is. It's something like a Raspberry Pi. That's like the common embedded computer that everybody knows about. Right now, when I needed to buy one, it was just sold out, so I wasn't able to procure a Raspberry Pi. So what I went with instead is an Odroid N2 Plus. And it's a very similar system. It's maybe a little more powerful. One thing that I really love about it is that like many of these other embedded computers, it has no moving parts. So all of the data is on an SD card. It doesn't have a fan for ventilation. So it's there's just like nothing moving, and that means that nothing can break. Especially because this is going to go, or this has already went into the wall closet where these relays are living. And I just want to be able to put it there and connect the Ethernet cable, stick in these two USB sticks, connect it to power, and thus just basically forget about it. And I want it to have like infinite uptime, and so far it has been great about that. It has been super reliable. So it's running Linux. And then one disappointment I had with Odroid is that the Linux kernel it supports out of the box is too old to run like new versions of Docker, so I wasn't able to get Docker to work. And as a result, instead of installing all of this stuff in containers, I just installed it bare metal. In the Home Assistant website, it says that this is like an advanced use case. It's actually not advanced at all. Like, you know, a couple of years ago, everybody was still doing everything on bare metal, so it's actually not a big deal. Okay, so on top of that, I developed my own C-based service that basically integrates the EnOcean's own driver, basically for this EnOcean gateway stick, so that it can send and receive the messages via like TTY socket communication from the stick, and then basically convert it to MQTT messages that it sends to the Mosquito server. And then that Mosquito server in turn sends the messages to Home Assistant. The Z-Stick communicates directly with Z-Wave JS, so my driver doesn't do anything with the Z-Stick. And then, of course, it also listens to MQTT messages like turn this particular switch on or off, and then it sends out that message. This basically lets me do all of the capabilities that you have in Home Assistant and mate it together with the EnOcean relay system. I hope that gave you guys a good overview about what I built. I am at this point not planning on making more videos. What I want to do is gauge the interest of the let's say, YouTube community in finding out more about this kind of EnOcean to Home Assistant bridging and any of the custom tech I came up with. So if you're interested in this, please comment and tell me what you would like to find out more about, any questions that you have, and then I can make a third video where I go over those questions and try to answer them. Thank you and take care.